So hi, today we will talk a bit about Dasharo open source firmware validation. We've talked about that, I think, once in a talk before. It was 2 meetings ago. So today we will have a brief introduction or reminder what that is. And generally we focus on the current state. So what we have accomplished so far, what are we working on right now, and what are our further plans. So what was the Dasharo open source firmware validation? So it's basically a test framework we've been developing over the years. We've open sourced it like 1 year ago. Obviously, the main purpose for that one is to validate the open source firmware as a namespace, but we are realistically validating Dasharo firmware right now only. We are using Robot Framework as a base for that framework. And what are the use cases? So obviously, testing Dasharo firmware releases. Each release is tested using the same growing number of tests, and we are publishing the results in various forms with each release notes. On top of that, we can use like single tests for test-driven bug fixing or new features development. We are using the regression testing after like introducing new features to see if we don't break any additional stuff at the same time, or after some major changes like rebasing the code or the EDK2. That's also helpful. Recently, we are also using that to validate other Dasharo-related tools we are introducing, like Dasharo Tool Suite or Dasharo Configuration Utility. We will also be discussing the second one at least today. And we want to explore the emulation part as much as possible, because that gives us great possibilities in terms of testing without hardware, because testing on hardware is always a trouble. In terms of the current state, there was no release, so there was no tag, we can say, since the last presentation, sadly. We are still in quite intense development or cleanups in the develop branch. All of our work targets this branch, so if you want to touch this repository, this is the branch you should take a look at, not the main branch. And our goal would be to aim for something stable enough to set a tag, merge it to main, and call it 0.3 version. And hopefully that happens before the next meeting in 3 months. Some statistics. It's just the first time we are showing that. Perhaps it will be more interesting meeting after meeting once we see the changes in terms of tests. But what we came out that might be interesting to see how many tests we have in total. So we have around 400 test cases in total, and additionally 66, we call it self-tests. Those are more like unit tests to sustain the correctness of keywords operations, so the functions we use within the test framework. The tests are still split in the so-called modules or directories. We also have a plan to maybe move that around a little bit. But we definitely can see that we have some compatibility where we put right now just some functional tests for like USB ports, display outputs, etc. We have some security suites where we put like management engine disable, write protection stuff, and so on. That's the general idea here. So in terms of recent improvements, so we take a look at the time frame since the last meeting, so around 6 months. We have some notable changes that we want to share. in more details in the next slides. Besides that, we just continue on some refactoring activities and typical fixes and minor improvements. So the first major change was well, we do that in many fronts. We noticed over the years it was maybe not that managed that correctly. The code base we've managed to develop. So one of the places where we've spotted a lot of duplication were configs. When adding new tests, new platforms, the configs grew and grew, and it was like 200, 300, 400 lines per platform. Many of that could be shared between the boards, but it was not. So it was copied over, and changes didn't propagate through the similar units. So that was a pain. So we just set up a simple include system, which is the typical approach, and that helps a lot in terms of readability and maintenance of changes in terms of platform configuration. Another change is the documentation. So we so far had no documentation at all. We had quite a long README. We are splitting it right now a little bit in more modules, we can say. Notable parts are like adding new platform. That is a new section that is very useful, because if you want to add a new board to the test environment, that's the first piece of documentation you are looking for. Some contribution guidelines, so we can onboard new folks to the project. Workflow with QEMU is, as I said before, important. We want everyone to use that. And some platform-specific quirks, because it's not always that easy. In terms of documentation, we are also so that's how the documentation looks like, basically. But okay, I have that later. I have the documentation split. So that's basically how the documentation of adding new platform looks like. So another notable changes is about SON-OFF. The SON-OFF is the device we are using to control some of the boards. For some of them, we can use just RTE and relay. Some of them cannot be switched that way, so we use some Wi-Fi devices to do that. And we flash them with some custom firmware. We just switched to another one, which we found out to be more reliable, and we just needed to change the corresponding APIs as well to control them. We have added some new tests, like checking for unexpected errors in system logs, like the message. These typically come from like either new features or bugs. So we created a new release. Some user reports like error they haven't spotted before, so we figured that out. We should have a test like that, for instance. Some watchdog suites. We've been releasing APU2 boards, so we have also added some APU2 specific features into the Dasharo menus. We have switched for the DCU tool, which will be also discussed. And we haven't checked before, some of the data we have in the main setup menu, like the CPU clock or memory size, whether it's displayed at all, and whether it's displayed the correct values for the correct platform. So that was also a problem in some, I think, MSI boards. What's next? Some new platforms, a lot of protected boards. They are not released publicly yet, like V1000 series, VP6000 series. We've added back PC Engines boards. We've had them years before in this repository as well, because originally it was meant to validate PC Engine's releases, in fact. But right now we have added them back as a Dasharo PC Engines with a UEFI payload. If you added Mio board turbot, Piotr was showing it on the roadmaps as well, and right now we are working on the Nova Custom Meteor Lake modules, so we need to validate them as well. So that was what we have developed recently, and that is what we are working on right now. So we have something already in place, but it's not finished, still being developed. So DCU integration, DCU will be discussed later in more details. It has a few features. One of them is like ability to modify firmware settings directly in a firmware binary. And we figured that we can use that mechanism also for testing to switch some, change the value of some firmware switch from the OS or from external flash shell. And that way, when we boot, we have the settings changed and we can validate in the OS, for instance, if the firmware switch has the desired outcome, like the EMA disable or network boot enable, for instance. So previously, so far we had only two ways of doing that. We needed either serial connection or PyKVM USB keyboard simulation. So we enter this. So we walk through these menus like a typical user would do. That's fine. That's probably even better because that's what users will be doing. But in some platforms, it's really challenging to do that, or maybe even using the DCU method can move the testing closer to the users because typically they don't have the specialized hardware, and maybe with the DCU tool, they can, with the DCU method used in the validation framework, maybe they can also run some tests on their hardware. Okay, so that was the second thread in the documentation I was looking for before. So it's documentation of keywords and tests. Robot Framework has some nice tools to generate them on the fly from the code, as long as we, of course, document the keywords correctly in the code. So we gave that a try. We need to structure it. We need to create some landing page because we have some several modules already with the keywords, and we plan to host it maybe on the GitHub pages at first, and then we will see. Another big priority right now we are working on is integrating low-level hardware operations in Python libraries, because right now, we'll show that in a moment, it's a bit mess. It's a bit of a mess. So the goal is like in this picture, we have a set of common Python libraries which deal with the low-level stuff, like talking to our control units like RTE or SONOFF, or talking to the Snipeit, which is our database for devices. Then we have very, very simple robot framework libraries that just passes some stuff from the Python libraries to the robot framework test environment. And in parallel, we have a CLI tool which uses the very same code, which we can just call whenever we want to control the platform when development, for instance. Okay, so here we want to explain what was the motivation behind this change. So this is more or less how it looks like before, or how it looks like right now. So it's a bit complex, and we have identified several problems here. So maybe let's start from the left. We have the control devices like SONOFF and RTE. currently on RTE we've been having some like scripts to control on-off and some scripts for flashing. These scripts are placed then by someone somewhere. They are not under any version control. They are crafted ad hoc for each platform because each platform has a specific flashing procedure, so they are not generic. So each RTE must be prepared specifically for each device under test. When, I don't know, RTE breaks, we have a problem because preparing a new RTE for this specific platform might not be that easy because it requires some customization. And so we have some like hardware primitives implementation in these scripts. And we also have some the similar or implementation, but not in Bash, but right now in Robot Framework in test environment. So we have a problem of having two implementations. So when you develop, you might have different results when controlling the platform than when you are running the test, which is not optimal to say the least, because you may have unexpected results this way. And we also have a duplication in terms of device information, because we need for each test stand we need various configuration parameters like various IPs, like for RT, for SONOF, for PyKVM, whatever we use here. So we used to have them in the code, like robot framework variables, but also in the snipes, which is again a duplication. Risk of desynchronization, and a lot of problems. So that is a bit complex. So we're trying to simplify it a bit. So right now we do have the common Python libraries. We just call whatever is needed, be it a SONOF, be it RTE, be it sniped. And both test framework and both CLI uses the very same code. So we don't have code duplication. We have minimum configuration per RTE, so we can easily swap new RTE for whatever device we have, because all of the logic with platforms is in a single repository, which is tracked in Git. So nothing gets lost here, and the setup effort is minimum. And we have reduced lots of code this way from Robot Framework, which is not only a plus because we reduced some duplication, but also it's really not a low-level language, Robot Framework. So like writing to files to set GPIO is not something Robot Framework is designed to do. In terms of device information, we want to use SnipIT database exclusively to be a single source of truth in terms of device configuration, possibly leaving some option to override it via some environment variables or so on and so on. For instance, for users who don't have such setup. So a few more words about this tool. It already works. We are slowly adopting it. How the typical developer usage scenario can look like. So we can reserve the platform. Maybe later on that process can also be automatic. So whenever you try to flash, for instance, the platform, it should check if it's maybe not, or maybe someone else is using that, but it's not in place right now. So we can read firmware, so to have a backup. Then we can flash new firmware. Then we can, for instance, apply power, so the platform boots. We grab logs from serial. We can reset. We can power on, power off, maybe flash again and repeat the process however we like, and we just execute some commands from our terminal to do that. What are the next steps for the whole test framework? We want to stabilize it for the 0.3 release. Basically, we would like to finalize the current task we have in progress, the ones we just discussed. And at the same time, we want at least selected platforms from the ones below to let's say fully supported, so we can run the full regressions on them without any major problems in terms of the test environment. Of course, we don't expect all of the tests to pass because it's very rare, but at least not a major problems in terms of like running the regression scripts. If you would like to help, you can go to the repository. You can possibly don't have the hardware required to run all of the tests, but QEMU can be a good start. You can try to run it. You can probably have some problems. Then you are very welcome to report them via Matrix channel or via GitHub repository. And via this way, you can be very much helpful, like to improve the docs or scripts for external validation, because I'm sure we have some internal knowledge that is obvious, and there is no need to document that stuff from our perspective. We started to adding some good first issue label. That's also might be a nice way to take a look at such issues which we can consider maybe easy to tackle, maybe can be solved entirely in QEMU, for instance. So that's it from my side. Any questions?
Yeah, thanks, Maciej. Like this was like really great overview what's going on. Maybe I will just add two cents from me. So the grand vision of the open source firmware validation framework is finally to deliver something which could do Dasharo certification. So the point is to achieve the level in which someone somewhere compiles the open source firmware and then wonder, okay, how good it is. Like, is it something that I can go with to production? Is it something that I can, I don't know, sell it on my devices, or I have to what I have to do? So right now, essentially, you have to do the manual tests, or you have to create your own framework for validating and making sure that the firmware, the BIOS you flash it, really contains some qualities. And the goal is to make open source firmware validation framework the framework for checking the open source firmware. And even like, for example, if you will wonder, okay, I'm taking this core boot commit, like random commit from core boot, and I build this binary, I flash it, everything boots, but is it good enough to make it your daily driver? Yeah, that's the question. So if you will have framework which can confirm that, then I guess this is something that that would be worth the effort. On the other side, we still have to deliver something like that because we're doing this professionally. So why not to deliver that also to the community? And that's I guess the grand vision. Like ultimately, maybe in future we could have something that that people could, or companies could self-certify stuff, or then let's say we run some tests on some core boot release or some core boot tag, and then someone figure out, okay, this doesn't work, that doesn't work, that doesn't work. Who can fix that? Okay, so some core boot consulting company can fix that, or maybe Dasharo people can fix that. So that's also kind of maybe at some point a revenue generation mechanism or a validation framework which can point and say what precisely 3M Dev have to fix. And it, of course, will lower the scope of evaluation for 3M Dev because then 3M Dev like get the test results and know what have to be fixed instead of doing the analysis, doing the evaluation of the platform, and so on and so on. Thanks to that, we can deliver, of course, more platforms which are running open source firmware. So that's also something that should help. So yeah, anyway, I don't see any questions.